Hello, geometry class. This is the last recorded video I'm recording for this school year. Chapter 8, Section 2, Properties of Parallelograms. This will be it, the last thing I'm able to cover. There's a bunch of stuff that I would have covered if we didn't have the COVID-19 circumstances. Things got, obviously, got pushed off the curriculum because of that. So I had finished the chapter that we had started. I had I would have planned to finish that chapter more quickly, the trigonometry, and then I would have done all of chapter 8, and then probably done a little bit of another chapter if it wasn't for this. But hopefully this is enough that you'll be good for the next year. I mean, geometry is a little different. You don't really need a lot of this stuff in Algebra 2. Some of it does translate, the trigonometry will translate, and some of this will translate to pre-calc, but I think you got enough that you should be okay when you come to it. And a lot of this stuff is also in the SATs, but you probably want to practice for the SATs anyway. You don't want to go into those cold. So hopefully you'll get anything that we missed, you'll get on maybe some practice that you do before the SATs. So, but I do want to talk about parallelograms. There's a bunch of a bunch of quadrilaterals. I'm going to focus on parallelograms. Parallelograms are the most common polygons, or sorry, quadrilaterals. A quadrilateral is a polygon with 4 sides. Rectangles, squares are the most common ones that you hear. Well, both rectangles and squares are a type of parallelogram. There's other types of quadrilaterals, kites, rhombuses, but we're going to just look at polygons here. Parallelograms, sorry. So a quadrilateral is a parallelogram if opposite sides are congruent. That means that sides opposite each other have equal length. Okay? All right. A quadrilateral is also a parallelogram if opposite angles are equal. Okay, the angle measures of opposite angles have the same angle measure. Okay. So these are two characteristics of parallelograms that are pretty important. So a rectangle will be a type of parallelogram. A square will be a type of parallelogram, but not all squares and rectangles are not all parallelograms are squares and rectangles. As you can see here, this is a general parallelogram. It's neither a square nor a rectangle. So while all rectangles are parallelograms, not all parallelograms are rectangles. Just like this is going back to the logic that we had at the beginning of the year, that all boys are humans, but not all humans are boys, right? So this is a subcategory of parallelogram would be rectangles and squares would be subcategory, but there are more than just rectangles and squares that are parallelograms. So the reason why a rectangle would meet these conditions is because opposite sides are equal, and at every angle is 90, so opposite angles are equal in a rectangle. In a square, all sides are equal, so opposite sides are equal, and still all the angles are equal in a square. All right, so let's do a problem. So they're giving us this, and they're letting us know this is a parallelogram by these arrows. These opposite sides are parallel. Did I mention that? Yeah, that's the definition of a parallelogram, is when opposite sides are parallel. Okay, so that also means that the opposite sides are equal and opposite angles are equal. So opposite sides are parallel, meaning this is a parallelogram, meaning that opposite angles are equal and opposite sides are equal. So we can actually just solve this by setting these equal to each other. So I'm solving for x first. I'm going to take x plus 4 equals 12 and solve that for x. Pretty easy. Shouldn't be too hard to get 8 for that. And as hard as that was, might have been, solving for y will be even easier because I'm setting these two equal to each other, and y equals 65. There's nothing to solve for because there's no pluses or minuses or anything else going on. We have just solved this problem, finding x and y, because we know that they're equal because of the parallel symbols, meaning it's a parallelogram, and because of the parallelogram, opposite angles are equal, opposite sides are equal. All right, the consecutive interior angle theorem that we looked at earlier in the year that states that two lines cut by states that if two lines are cut by transversal, consecutive interior angles work a consecutive pair, which means that they add up to 180. Okay. Well, this is actually like half of a parallelogram here. So if you think about a parallelogram, um, let me see. Let me go back up to this one up here. Sorry. So if this side here is equal or parallel to this side, and then this is the same as cutting that parallelogram with a transversal. Okay. Well, the property that we learned that these two add up to 180 will hold for a parallelogram, which means that any two consecutive angles, we know opposite angles are equal, but any two consecutive angles will be adding up to 180. So if I take any pair that are next to each other, so these two here, these two right here would be add up to 180. These two here would add up to 180. These two here would add up to 180. These two here would add up to 180. All the while, opposite angles are still equal. Okay? So that's just how this is going to work. So for instance, if I could give you this angle measure here, right here, this YP, if I told you that was 60, that means that this would up here would have to be 120. Okay, because these have to add up to 180. And then this here would have to be 60 because these have to add up to 180 and these have to be equal. And then this would be 120 because these have to add up to 180 and these have to be equal. And we have a 120 and a 60 which add up to 180. So they all just kind of fall in place. If you only would need to know one measure and you can find out the rest because of that. Consecutive, and it goes both this way and this way, that every consecutive two angles next to each other have to add up to 180. Okay, so example 2. So we have a lamp, as shown below. Part of the extending arm of the lamp is parallelogram. The angle measure of the parallel change. The angles of the parallelogram change as the lamp is raised and lower. Okay, that's pointless information. We don't need to know that. Find BCD given ADC. So we're given this angle down here. ADC is 110. Okay, they want to know what BCD is. We could actually find all of the angles if we wanted to. And so angle C is what they want. They've given us angle D. Okay. Well, we know that these two have to add up to 180. BCD plus ACD have to add up to 180. And we know that ACD is 110. Just have to subtract 110 from both sides, and I get BCT is 70. Pretty straightforward stuff there. Okay. Diagonals of a parallelogram. The diagonal of a parallelogram is a line drawn from opposite vertices. So if you connect those opposite angle points, we will have a diagonal. Well, diagonals, if you draw two diagonals meeting the opposite angles like that, they're actually going to meet at a point that cuts both diagonals in half. Okay? So they bisect each other. That's what that means. So this is cut in half exactly, and then this is cut in half exactly in half. So there might be some problems given to you where they ask you to find measures and they give you. So for instance, they want us to find NM here. Well, we know that this cuts the KM in half. Okay, so that means KN or NK and NM have to be equal. So NM will be 2. This is 2, but this will be 2. Okay, the total thing KM will be 2 plus 2, which is 4. Okay, now they're asking for angle JML. Okay, they give us angle KJM. KJM is given. They want JML. Well, we know that these angles are next to each other, so they have to add up to 180. Let me do something here real quick. Instead of scrolling back up and down, I'm going to move this image here so I don't have to scroll up and down. Okay. Oops. So we know that KJM and JML are next to each other, so they have to add up to 180. So 110 plus this angle measure here adds up to 180. Subtract 110 from both sides, you get 70. Oh, that's the same as the one above. That's interesting. Not all these answers are 70. Now they're asking for KML. KML. The way to find KML, which would be this angle measure right in here, just this angle measure right in here, is that we already know what JML is, and we can see that they labeled what JMK is. Okay, this angle here. Okay, so it would be this measure plus what we're looking for is equal to the total that we just found of 70. Okay, this plus what we're looking for has to add up to 70. That's what we just found. And subtract 30 from both sides and you get 40. Okay, so there's some problem. There's going to be some problems with parallelograms, and then this will actually be it for the school year. This is the last section that I'm covering. There'll be a few extra days at the end of the, because this will be due on a Wednesday, and then this will be June 3rd, I think. Wednesday, June 3rd. School is done the 5th, so try to get this in early. Whatever the assignment is, I'll post the assignment in Google Classroom. I don't want to show it here because I don't know if I'll change it. So if you get it in early, and then I can get it back to you, and you can make corrections. You'll have until the 5th to get anything that was assigned or that was due in May in. To get any of your fixes in will be the last day of school, June 5th. You have until then to get that in. Thank you and good day.